You can't outrun a rabbit. You can't outrun a deer, a kudu, or almost any animal you'd ever want to hunt. No claws, no fangs, no venom, no fur thick enough to survive a real fight. Over short distances, humans lose to nearly everything with four legs. So, how did a slow, clawless, fangless primate become one of the most dominant hunters on the planet? The answer isn't speed. It's something almost no other large animal on Earth can do. You can keep going for hours. In 1984, biologist David Carrier proposed something that seemed almost absurd at the time. He argued that human endurance running wasn't just exercise, it was a hunting weapon. Over long distances in the heat, humans could run down animals that could outsprint us in seconds, but couldn't outlast us in hours. Here's the mechanism. Most four-legged animals cool themselves by panting, but panting is tied to their breathing, which is tied to their gait. When a horse or a dog gallops, its ribcage compresses with almost every stride, forcing it to breathe at close to one breath per stride, no matter how hot it gets. It cannot run and cool itself at the same time. Not efficiently, not for long. Humans don't have that problem. We sweat. Millions of sweat glands across nearly hairless skin, cooling us continuously, whether we're breathing hard or not. And because we move upright on two legs instead of four, our breathing isn't locked to our stride the way a galloping animal's is. We can vary our breathing independently of our pace, in a way almost nothing else built for speed can do. Humans aren't the only endurance hunters either. Wolves and African wild dogs also wear prey down over long distances, but they do it as a pack, taking turns, relaying the chase, so no single animal has to sustain it alone. A human doesn't need a relay. One person, sweating, breathing freely, moving at a steady pace, can do what usually takes a coordinated group of predators working together. So the strategy isn't to be faster, it's to refuse to stop. Chase an animal in the heat of the day, not fast enough to catch it immediately, but persistent enough that it can never fully recover. It sprints ahead, it waits, it's found again, it sprints again. Each time, it has less time to cool down. Eventually, its body temperature climbs past what it can survive while moving, and it collapses from heat exhaustion, exactly where the hunter finds it. In 2004, biologists Dennis Bramble and Daniel Lieberman published research identifying the physical evidence for this in the human body itself. A long, elastic ligament in the back of the neck called the nuchal ligament that helps stabilize the head while running, found in humans and horses, but not in chimpanzees, our closest living relative. An enormous gluteus maximus, a muscle that does almost nothing when we walk, but fires hard the moment we start to run. A springy arch in the foot, and a long Achilles tendon that store a significant portion of the energy from every stride and release it back. Like a natural shock absorber no other primate has. None of these features exist for walking. They only make sense for running long distances on purpose. This wasn't theoretical. In 1990, researcher Louis Liebenberg joined a group of hunters in the central Kalahari Desert at a place called Lone Tree to document persistence hunting directly. The trackers found the footprints of a kudu, a large antelope that can easily outrun a human in a sprint, and set off after it on foot at a steady jog in the hottest part of the day. They didn't try to keep the kudu in sight. They tracked it instead, reading footprints, disturbed grass, the direction of its panic. Every time the kudu got far enough ahead to rest, the trackers found it again, and it had to run before it was ready to. In under 2 hours, the animal collapsed from heat exhaustion, and the hunters walked up to it carrying nothing more than handmade bows. But the running was only half of it. Liebenberg went on to argue something more surprising, that persistence hunting required a kind of thinking we don't usually associate with the deep past. To follow an animal you can't see, for hours across changing terrain, a tracker has to build a mental picture of where it is, test that picture against new evidence, and revise it when the tracks say otherwise. Liebenberg spent decades studying this and concluded that tracking wasn't just a physical skill, it was reasoning, hypothesis, evidence, revision, the same basic process science runs on today. He argued that persistence hunting may not only be the origin of endurance running, it may be one of the origins of how humans think. A 2024 study found hundreds of recorded cases of this exact hunting method, practiced on every inhabited continent. Not a fluke, not a one-off survival trick. A strategy old enough and widespread enough to have shaped what a human body, and possibly a human mind, actually is. Now here's where it gets complicated, because not every researcher agrees on how important this really was. Critics point out that documented persistence hunts, even Liebenberg's own, are rare events carried out by a small number of specialists, not an everyday hunting method. Successful chases can take hours and still fail most of the time. Some researchers think our ancestors relied more on scavenging, ambush, and tracking down wounded prey after a thrown spear, with full persistence chases reserved for specific conditions. The right heat, the right terrain, the right animal. Some argue that walking prey down, not running, may have come first, and that full persistence, hunting by chasing, may be rarer and later than the popular version of this story suggests. The debate isn't really about whether humans can run animals to exhaustion. It's about how often and how early anyone actually did. The practice had mostly disappeared by the time modern researchers started looking for it, which means we're reconstructing something that almost vanished before we understood what we were looking at. But even the skeptics agree on this. The body you're sitting in right now was not designed to sprint. It was designed to keep going, long after a faster animal would have quit. You can see the same machinery at work today, just repurposed for a different reason. Ultra-marathon runners now cover distances that would be unthinkable for almost any other primate, using the identical cooling system, the same springy tendons that once turned an exhausted kudu into dinner. The context changed completely. The hardware didn't, which means the next time you go for a run or push through the last mile when your legs want to stop, you're not fighting your biology. You're using the exact adaptation that once led an animal with no claws, no fangs, and no real speed walk into a landscape full of faster, stronger predators and become the one everything else had to watch out for. Not because we outran anything, because we simply refused to stop. And because somewhere along the way, refusing to stop turned into a way of thinking. Not just a way of moving,